Hello everyone, this is Team 1. Our project is UAV flight control with obstacle avoidance system. There are 4 people in our team: 吉庆里、于曼阳、于段、邱宇涛, and our faculty advisor is Professor Wei Wei. Here is today's agenda: problem description, design process, requirements, design overview, project limitations, and project demonstration. There are 4 main problems in our project. First, the data, including distance and angle, captured by the LiDAR may be unstable. Second, we try to achieve LiDAR detection for 360 degrees. Third, quadcopter should avoid all obstacles, including tiny holes, lines, and masts. It will be a difficult target. Third, we should combine LiDAR and the quadcopter together successfully. There are 2 different ways to deal with the data: wavelet transform and fast Fourier transform. We compare 2 transforms and found that there are some benefits of wavelet transform. It is more suitable for processing unstable signals, and it includes 2-dimensional information, both time and frequency, and it focuses on any detail of the signal being analyzed. But the fast Fourier transform is more widely used because it is more mathematical than wavelet, and it requires very low computational resources. Here is a structure chart of UAV automatic avoidance system. It includes 3 models: data acquisition model, data fusion processing model, and obstacle avoidance control model. It contains many units. Some problem will occur in some units, but you can find it quickly and solve it. The UAV automatic avoidance system can be used in many areas. Here are some applications. It can be used in express industry. UAV can express delivery to save the cost of labors. Aerial photography, it is very popular right now. Field research and rescue, disaster monitoring and environmental monitoring, and it can also be used in tactical reconnaissance.
Okay, so the next part is design process. First, we obtain the design direction. That means we develop through brainstorming meetings and discussion with faculty advisor. Then we perform literature review of current research. We review published general articles to gain understanding of current research and area for improvement. Then we adjust a quadcopter and LiDAR. That means 3 steps. The first step is try to use the rotor to control the UAV flight. Second, we run LiDAR and read data from the LiDAR. Third, interface LiDAR and quadcopter. Last, we achieve the automation of quadcopter. First, we use SILT to write code. Second, debug in a simulate environment. Third, build obstacles to real test. This slide is about the function mainstream. That include device functions and methods to achieve that function. In the middle of this chart is detect and perception layer. Below this is a flight control layer. So let's begin from the right lower corner. You know, the UAV have the perception system, so it can detect the environment information around. Then they will get the obstacle information, so the information will transmit the data to the obstacle avoidance control. So it can control the flight control system, so makes the UAV avoid collision. This part is about design requirement. our design have 8 main functions. The first one is long duration. We gonna increase battery life and reduce charging time. And the second one is the low weight. We will choose the lighter as light as we can to reduce power cost. The third one is easy to operate. That means we can easy to operate UAV to avoid obstacle. 360 degree scanning lidar. Quadcopter should can detect obstacles for all horizontal direction. We need a lidar which can rotate for 360 degrees. Safer job with obstacle detection. And then it's obstacle detection for easy of mind. We gonna use the WT to calculate the signal data to find out the distance and angle of the collision. Then the last one is path planning optimization. LiDAR can calculate out a good path for quadcopter to avoid collision. The last one is detect obstacle accurately. UAV can detect all kind of obstacle and find a path to avoid them. This part is about assessment metrics. For long duration, the metrics is the duration of a flight is 20 minutes to 30 minutes. Next part consumption is the weight of the UAV is 700 gram to 1 kilogram. Easy to operate. If everyone can easily operate, do not need complex control. 360 degrees scanning lidar. The matrix is lidar can rotate for 360 degrees. Safe. It means efficiently avoid obstacles, ensure the safety of aircraft, people, and surrounding environment. Obstacle detection for easy of mind. Is use WT as a base calculation of data string. Then according to the RPA lidar, it is capable of up to 4,000 symbols per second. It is a great number of data, but it is complete. The path planning optimization. When the quadcopter with lidar detects the barrier like the tree, and then by the inside controller with the algorithm of route planning, it set a new path to avoid collision with trees. The next one detects obstacles accurately from the length and the width of the obstacles. The quadcopter can tell all kind of obstacle it meets. We will import different data of the obstacle before. There will be a database inside of quadcopter. Comparing the data, it can find the path.
And here is our design overview, and this is our black box diagram. And the input is the collecting peripheral information by the Lightwell SF11/C LiDAR sensor, and it's passed to a black box. It's a fully developed data analysis system and route planning algorithm, and then it will help the quadcopter to successfully avoid obstacles while flying. And for the detail of the black box, the inner part is about the data will be sending to the Pixhawk flight controller, and the flight controller then will analyzing the data and calculate the obstacle population. And after we get the obstacle location information, and we will find a new route for the copter, and the flight controller will send the operating signals to the motors. This will help the quadcopter to successfully avoid obstacles. And this is our morphologic chart. It's a vero chart used to figure out the necessary design functionality and explore alternative means and combinations of achieving that functionality. And for each of functions, there are 4 options. For the controller, we have PixHawk, Pix4, Navi Plus, Uriel Brain 2, and for the LiDAR, it has LiDAR Light 3 LiDAR, Lightware SF11/3/C, HDL32E LiDAR sensor, Park VRP16 LiDAR sensor. And the battery has also 4 options. It's 10 to 6 pix, Keystone, Teenager, TO0, and for the ground station, we have Mission Planner, APM Planner 2.0, and MapProx, and UGCS. And for the multicopter frame, we have IRIs code X8, Y6, and Hexcopter. And considering the cost and our need, we finally chose the PixHawk for the controller, and Lightware SF11/C for the LiDAR, and the TO0 for the battery, and the Mission Planner for the ground station, and the IRS code for the multicopter frame. And finally, this is about our bill of material, and we can see the Lightware SF11/C LiDAR sensor is the most expensive part. It's about $269, and for the PixHawk, it's about $16, and the battery, $3 for each one, and we need 4, so it's $12, and the motor is $14 for the total, and the frame is $19, and the campsite is also $20. So our total implementation cost will be $421.
Next, I will introduce about the limitations of our project. And we have 3 main limitations of our project. The first one is speed of the route planning, and I will talk about what is the limitation of this. We have mentioned about that our route planning we use the LiDAR to detect the obstacles around the UAV. So, but we cannot use the LiDARs to detect all the direction in one time. So the LiDAR will rotate in 360 degrees, and when the LiDAR finds that there's no obstacles in one direction, that means this is the route that the quadcopter can go through. So the speed of our routing planning is very low. The LiDAR will detect the direction and then choose a better route to let the quadcopter to go through. And the second one is altitudes. And the altitudes, we know that in our project our quadcopter cannot reach a very high altitudes. So it only can reach maybe a medium altitudes, maybe about 30 meters to 60 meters. And in the next slide, I will introduce this. In this slide, we can see that if the altitude is over 90 meters, there's very few obstacles. There's only skyscraper and maybe some problems. So the higher the altitude the quadcopter can reach, the fewer obstacles there is. But our project only can reach to maybe from 30 meters to 60 meters. So in this level, there's lots of obstacles. For example, aerial cables, trees, and house, and especially in this level, the trees and house and and area cables is very essential for our quarter cables, which means these things can destroy our project. So the limitation of our altitudes of the capitals also give us a very big problem about how to actually avoid the obstacles in this level. And then I will another limitations about the batteries. Our capitals has some limit of the weight, so it cannot have lots of batteries with it. And here are some different types of the batteries. The first one is a fossil, and with research about these fossils from HUS company, Singapore company. They also have a quarter captor, and the weight of their fossils is 1 kilogram, and this battery can last more than 115 minutes. And the second battery is a hydrogen fuel cells, and this kind of fuels can use more than 20 minutes. And the third battery from Britain, the solar cell panel. And this kind of battery is very good, but it's continuous studying. So we also can use this. What we can use is lithium battery, and we find one of this kind of battery from Tesla. The capability of the lithium battery from Tesla is 10,000 milliampere hours, and this kind of battery can use more than 60 minutes. But this kind of battery is very expensive. So in the end, the battery of our project maybe only can use for 20 minutes to 40 minutes. So it's also a limitation of our project. That means if we use our project to detect some things, we cannot let it work a very long time. And finally is project demonstration of our project right now. You can see these two pictures is a simulator of our project. We use this in the Windows Microsoft, and in the computer we use some virtual machine in our Windows computer, and use Linux to simulate our project in this system. This is two pictures of the simulators. And finally is our project, a quarter capture. And finally we will use this quarter capture to work in a black box, which means it will fly in the black box and detect the obstacles, and then it will find the outlet itself. If our project is successful, the quarter capture can finally find the outlet itself. Thank you.